Okay, so this is a follow-up to the previous video in which I solved for the coefficient of friction to keep this ladder from falling down. So that's what I did. Um, and here's the beginning part. So I had this ladder, I had a length, I had the distance the person was going up, all this stuff. And then I did this. And you need to go back and watch the video. But I had set up all the forces on the ladder, and I set up three equations: the net force in the x direction is 0, the net force in the y direction is 0, and then total torque about any point is 0, and I picked this point down here. And then I used the definition of the frictional force, actually it's right over here, and then I got this. I got these two equations, which you could combine to be one equation, but I didn't because I didn't really feel like it. So I have the coefficient of friction, which is what I was trying to solve for, as related to the normal force for one of the ladders and the mass of the whole thing. And then I have this expression for that normal force. So these two equations really give me the whole problem. Now, I didn't stop there. I actually posted a link to this. I didn't show it, but here is my Python calculation for the same thing. So what I did, and I think this is an important point, Python or any type of programming language, really, I just like Python, I'm a big Python fan, is really great as a calculator. You could punch all this stuff in on your calculator and get a value. I personally hate calculators now. For the past 10 years, I kind of just don't even have a calculator. I just use Python. So Python is a good calculator. And you may say, oh, well, that's all great, but I can't use Python on my test for in my physics class. Yeah, that's a mistake. I mean, I'm a physics professor, and I let my students use Python on their tests. Okay, so that's that. But let me just show you what I have here. So I put in my my values that I have straight from the same problem. There's no units in these numbers because, and I'd like to make one other comment. I am a sloppy coder, and that's okay. Do not think that you have to have everything perfect with functions and perfect comments and stuff like that. That's going to just prevent you from getting into this. So just if it's terrible, if it's done in a really sloppy way, that's okay. I mean, you can get better later, but you got to start somewhere. Don't let that intimidate you into writing something. And then I'll link to this code, and you can edit this in a web page, and you can run it. You can see what happens, and you should do that. Okay. So you could put units here and everything, but these are the exact same values that I have in the problem. And then here in line 10, what I have is a equation to calculate the normal force N2. Okay. And I don't even care what it is, but I can calculate that. And the nice thing here is I'll show you in just a second. I don't have to solve for N2 and plug it in here. I can just write another equation for the coefficient of friction right there. And then I can print the coefficient. Why is it slow? There you go. So there's your coefficient of friction. And now let's say you wanted to change the coefficient of the angle to, let's say, 75 degrees. And then I don't have to do anything but change that number and I can rerun it. So that's the beauty. I have the equations in there and the numbers are kind of separate. They're not a calculation. It's not the numbers. It's more than that. Okay, so this is what's really great about Python, but it gets even better. Let me show you what we can do. Okay, so let's copy this code. So if you're not familiar, this is trinket.io. It's a website. There's other places that you can write Python code. I like Trinket because it's easy to share with people. They don't have to log in to edit it. They can run it, and if they want to save it, they have to log in, but they don't have to save. So that's why I use it. Okay, so here's my program. And what I want to do is to make a graph. I want to see how the minimum coefficient of friction changes as that ladder gets at different angles. So let's do it this way. So the first thing I'm going to do is make a graph. So now you don't have to make it. Let's make a simple graph, okay? I'm just going to say F1 equals G curve, and then I'll make it better later. That's it. Okay. So this G curve is a built-in function in VPython or GlowScript, which is same thing, you could call it either way, that makes a graph. So let me just run it just like that, and I'll show you what happens. Actually, I don't think anything will happen. Okay, nothing happened. So, but what if I go down here and I plot? What I want to do is change the angle and plot the coefficient. Okay, so if I do this, F1, and F1 is just a name. You could call it whatever you want. F1.plot. I want, what's my x coordinate want to be? I want it to be the angle theta. So let's just put theta, and then the y coordinate I want to be mu. So I have one data point, and if I run that, I'll get a graph with one data point. Boring. And my one data point's right down there, I think. Okay. So it doesn't really tell you too much. But now what I can do is change the angle and rerun everything and make a new data point. And I can do that a whole bunch of times. I'm going to do that so many times, it's going to make a line. That's what we're going to do. Okay, so let's move this. Don't need that yet. Let's get rid of the print. So what I want to do, what angle do I want to start at? Let's start at, let's say, a 45-degree angle. And I just like to think in terms of degrees. I don't know why, just maybe how I started learning physics. But Python calculates stuff in radians. So I go ahead and write 45, and then I multiply by pi times 180 to convert it into radians. Now the next thing I know, I'm going to calculate the coefficient with this angle, and then I'm going to change the angle and recalculate. So how much do I want to change the angle by? Let's just do 1 degree. So I'm going to call this d theta. Did I spell it? Yeah. D theta equals 1 degree. So I have to, again, multiply by pi divided by 180. Sorry. Okay. Now what I'm going to do is I want to calculate this from an angle of 45 to, let's say, 85. I don't want to go all the way to 90 degrees because I'm not sure. I think it would work, but I'm not sure it wouldn't explode. So we can always change it later. So I'm going to make a loop. So I'm going to say while theta is less than 85 times pi divided by 180, do the following. So in Python, a loop, there's multiple kinds of loops. While loop is probably the easiest to understand, I think. And like I said, there are lots of different ways to do this. This may not be the best way. I focus on the simplest way to do it, the one that's easiest for you to understand as a beginning programmer. So this statement 12, while, does everything below it that's indented until the following statement is not true. So once theta becomes greater than 85 times pi over 180, it stops. Okay, everything that's indented. So the first thing I want to do is calculate these two things. So I'm just going to indent these. So now they're in the loop. And now I want to plot my data point, f1.plot. And again, I want to plot the x coordinate. I want it as theta. And let's do it in degrees. So I'm going to plot it. Say I need to say times, 180. Yeah, 180 divided by pi. Got to convert it back to degrees because that's what I want. Yep. And then the coefficient of friction mu. Now, one other thing, this would run forever and it would never end. So I need to increase the value of theta. So theta equals theta plus d theta. And so if you're also new to programming, this line 17 looks weird because it looks like the theta value cancels because it's on both sides of the equation, but it doesn't because this isn't an equation. This equal sign is an assigned variable. It says take your value for theta, add d theta to it, and make that the new value for theta. That's what that means. So it's not an equation. But I think that will work. Let's just run this. I guess I should save it. Okay, now let's run it. There you go. Okay, so this says at a 45-degree angle, I need a 0.7 coefficient of static friction in order to prevent the ladder from falling, and then it gets less and less as I get down closer to 90. And I think at 90 it would be 0. So let's just go over here and change this to 90 and run it. Yeah. Okay, so it gets right down there close to 0. It actually doesn't get to 90 because Once it gets to 90, it stops. But there you go. And that's as simple as you can get, right? So I can change other things. I could say, okay, what happens as I change the mass of the person? What happens if I change the mass of the ladder? What happens if I change how far up the person goes up the ladder? I can do all of these things. Okay, now I want to show you one more thing, and I'll let you play with this. You may say, I want to turn this in for my lab report, but there's no axes on the graphs and it looks terrible. That's true. Okay, so up here I can say tgraph is an object of type graph. That's a built-in object in VPython. And so in this I can give it an x title. The x title is the label for the x-axis, and let's say that's equal to coefficient max. No, min. It's actually the min coefficient of static friction. And you should spell it right, but you don't have to spell it right. If your thing is, hey, I like spelling things wrong, then you should spell it wrong. It's your graph, right? Y title equals, no, wait, this is the angle. That's the angle, so I got these backwards. So this is X title. Y title is this. Sorry. But I like to make mistakes. Mistakes are just part of programming. So the X title is going to be the lean angle in degrees. Okay, now let's run it and see what happens. Check that out. Isn't that nice? Okay, wait. We can make it even better. Okay, I can put a whole title for it. Title equals leaning ladder problem. Now let's run it. Look at that. Okay, wait, it gets better. Okay, I can change the color of this curve. I don't know why. Blue is just my thing. You can do everything that you'd want. You can turn off the grids. You can make it prettier. You can have 2 lines. Okay, I can make another graph over here, F2. It may not really work too well, but no, I'm not going to do that because I'd have to change 2 different things. Now, let me show you one more thing for this graphing because this is super useful, even though it doesn't completely work anymore, I don't think. But let's say over here, if I add this parameter, and if you're curious, let me show you also. GlowScript. If you go to glowscript.org, which is the same thing, and click Help, and then go over here to Work with 3D Objects, Graphs, all the details are here. Okay, so you can go look at that. But let's go back over here, and I want to say fast equals false. Watch what happens when I do that. Okay, so the graph looks different because it's actually plotting this in Plotly. Now, you can save it. You can scroll the axes and stuff. You have a lot more control over the graphs, more interactive. It should open in Chart Studio, but the last time I did this, it didn't work. Yeah, it for some reason doesn't function right now. Okay. Well, maybe we can get that to work in the future. It's not my thing. Okay, so don't worry about that. But you could save this in Plotly and work on it there too. Okay, but that is a very quick introduction to parameterizing a problem and seeing how things change. Instead of just getting one number, you really get all the answers. I see how does this thing change as I change one of the values. But I have to do that with some type of programming language. Okay, so I'll link to this code below. I'll link also to the previous problem. Go play with the code. You're never going to learn unless you get in there and break it. And I will talk to you later.